In December 1968, the Berowra-Hawkesbury River section of the Sydney-Newcastle Expressway was open to traffic. The final section of the 10 miles of the expressway north of the Hawkesbury was opened in October 1966. In June 1966, the department commenced construction of the expressway between Berowra and Hawkesbury River through rugged terrain such as this. Clearing of trees and undergrowth was the first operation. The cleared material was placed in heaps and burnt. Eventually, the route of the expressway to be became apparent. It can be seen adjacent to the Pacific Highway. Once clearing was completed, the limits of the construction were established by the surveyors to enable work to commence. Before major earthworks could start, cross-drainage culverts had to be constructed in fill areas. These culverts were either reinforced concrete pipe or box. A 2-cell, 6 by 5 feet reinforced concrete box culvert was built under the highest fill. The height of the fill was 215 feet. $5.5 million cubic yards of rock were moved during construction. 60% of loosening was carried out by ripping using giant bulldozers fitted with single-tine rippers. At one time, 27 of these machines were used. The balance of loosening was done by drilling and blasting. The main explosive was an ammonium nitrate fuel oil mixture. A full range of delay detonators was used to give better fragmentation. Each blast was inspected for safety after firing, before work recommenced. To ensure that the faces of the cuttings, one of which is seen in the distance, were clean and true to line, they were pre-split prior to removal of material. This diagram illustrates the pre-splitting technique. After clearing was completed, 2.5-inch diameter holes up to 40 feet in depth were drilled at 3-foot centers along the correct line and down the correct slope of the cut face. Sticks of gelignite threaded on instantaneous fuse at 4-foot intervals were lowered into each hole. The charge was then exploded and a crack developed along the line and slope of the drill holes. The material in the cutting was then removed and a clean, stable cut face remained. The bulk of the earthworks was removed by motorized scrapers. Most of these machines could carry up to 30 cubic yards. scrapers can deposit their loads whilst on the move. At the height of construction, 20 of these scrapers were in use at one time. The balance of the material was moved from the cuttings using large dump trucks, which were loaded by front-end loaders. The largest cutting involved the removal of over 1 million cubic yards of material and was 140 feet at its deepest point. It passed right over a railway tunnel. The bottom of the cutting is approximately 70 feet above the roof of the tunnel. Extreme care was taken during excavation, and blasting was carefully controlled to avoid damage to the tunnel. Every endeavor was made to reduce the extent of interference to traffic flow on the adjacent Pacific Highway. After being hauled to the fill areas, the material was spread in layers, approximately 12 inches in depth, and compacted. The equipment used consisted of drawn sheep's foot and vibrating rollers. Peak daily outputs of up to 25,000 cubic yards were achieved. In order to expedite construction, 2 shifts were worked for several months. Fillings were faced with large rocks removed from the deposited material. The rocks provided a scour-free surface with a pleasing appearance. Subsoil pipes were laid in each cutting to ensure the removal of groundwater, which would affect the stability of the finished pavement. On completion of subsoil drainage and earthworks, the surface was trimmed preparatory to placing pavement materials, consisting initially of 12 inches of selected sandstone. The second layer of pavement material consisted of 8 inches of crushed basalt base course, which was spread by a special machine and compacted. After compaction, the surface was trimmed using a grader which worked to level pegs set in the base course or by an automated road trimming machine which worked to a preset string line. A layer of 3/4 inch gauge asphaltic concrete, 2 1/4 inches thick, was then placed and compacted. The pavement shoulders were then flush sealed with bitumen. The limits of the shoulders were defined with malthoid masking strip. and finally the shoulders covered with 3/4-inch crushed river gravel. The texture of the shoulder was coarser than the central pavement and created different tyre sound, obvious to the motorist. Finally, an asphaltic course, 3/4 of an inch thick, was laid on the traffic lanes, using 2 or 3 paving teams working in echelon. Outputs of up to 1,550 tonnes per day were achieved. An extrusion machine, which operated to a preset string line, was used to place both cement and asphaltic concrete curbing. To enable the expressway to be constructed to a high standard of alignment, it was necessary to relocate the adjacent Pacific Highway at 4 points. The main Northern Railway line was also crossed at 2 points. As part of the building of the expressway, 4 bridges had to be constructed. The first formed part of a relocation of the highway over the expressway. The second is a footbridge which provides access for bushwalkers. The third is a new railway bridge to carry the line over the expressway near Barara. And the fourth carries the southbound highway over the expressway within the Barara interchange. The first bridge has an overall length of 270 feet and is 34 feet wide between curbs, providing 3 lanes for highway traffic. This bridge is of continuous deck construction with hinged struts and ties. The structure was cast in place, and both the deck and ties are post-tensioned. The footbridge, adjacent to Cowan railway station, is of 2 spans, each 80 feet long, and is 12 feet wide. This width will permit the passage of bushfire tenders, should such be necessary. A feature of the construction was the pumping into place of the deck concrete in 1 pour. The total quantity of concrete poured was approximately 150 tons. The structure was cast in place and post-tensioned. The third bridge is of 2 spans, each comprising 6 girders, 82 feet 6 inches long. The girders were precast nearby as single units, post-tensioned, and lifted for transportation to the bridge site. The weight of each girder is approximately 63 tons. On completion of the bridge, the railway line was transferred to it by the Department of Railways, and the old embankment was removed to enable construction of the expressway beneath. The fourth bridge is of 2 spans, each containing 4 girders, 100 feet long, and weighing approximately 60 tons each. The girders were constructed by contract in segments, which were assembled, stressed nearby, and transported to the bridge site. Exposed aggregate fascia panels were placed on the outside girders of both the 3rd and 4th bridges, giving a good appearance. To provide connection between the Pacific Highway and the expressway, an interchange was constructed at Berowra. Provision has been made in the present construction for the future extension of the expressway towards Sydney. Through traffic will not then use the interchange. One of the many safety features incorporated in the expressway are corrugated steel guardrails on the outside of high fills. And also within medians, separating opposing traffic. Lighting has been established at all situations where important driver decisions have to be made, particularly through the Berowra interchange. Special lighting within the central portion of the interchange is provided by 9 100-foot-high lighting masts, surmounted by 4 1,000-watt lanterns. Square white reflectors and white ceramic dots attached to the pavement form the lane lines. Reflectorized white edge lines are painted on the pavement. Curb lines and outer edges of the carriageways are delineated by reflective markers. Great care has been taken in the design and location of road signs. Advanced direction and information signs ensure that no confusion is experienced by motorists. White letters on green indicates expressway, and white on black the Pacific Highway. The more important signs are illuminated at night. Emergency telephones have been installed at suitable intervals along the expressway. These telephones are connected to a central control where a patrol wagon is stationed. A safety ramp has been provided on the steepest downhill section on the northbound carriageway. The expressway between Berowra and Hawkesbury River was officially opened on the 13th of December 1968 by the Honourable P.H. Morton, Minister for Highways. Car drivers with the exact change can use the automatic toll barrier, whilst manual collection is provided for all other vehicles and cars where change is required. The construction of the Berowra interchange necessitated the re-siting of the Department of Motor Transport's lorry checking station. Buildings were erected to cater for both highway and expressway traffic. With the completion of this section of the Sydney-Newcastle Expressway, which cost $13 million, another serious traffic bottleneck has been removed from one of Australia's busiest highways, thereby providing 16 miles of expressway of world standard. Every endeavour was made to avoid scarring the landscape during construction. Regeneration of natural growth and landscaping was a special feature. The state of New South Wales can be proud of the achievement of those associated with the design and construction of this major project.